I'm Bailey with Vex Robotics. I'm here to introduce to you Byte, the hero bot for the VexIQ Robotics Competition Full Volume. This year, the hero bot was designed with the VexIQ 2nd Generation Competition Kit. If you have a Generation 1 competition kit and would like to upgrade, we offer a VexIQ 1st Generation to 2nd Generation upgrade kit that does not include the electronics, but does include all the new mechanical parts that you will need to build this robot and any other robot designed with the VexIQ Generation 2 system. Byte is made up of 3 subsystems: the drivetrain, which allows the robot to move around the field, the arm, which allows the robot to lift blocks, and finally, the intake at the end, which allows the robot to pick up and release the blocks. Each of these subsystems is driven by 2 motors each, for a total of 6 motors used on the robot. Remember, the rules only allow for up to 6 motors on your robot. This means that if you're going to add a mechanism to Byte that requires a motor, you'll need to remove one from one of the subsystems. The drivetrain uses 4 omnidirectional wheels. The back wheels are driven directly off of a motor, while the front wheels are free spinning. Having 4 omnidirectional wheels allows the robot to align with the field and the field elements easily. If you hit the wall of a goal at a slight angle, the wheel can roll sideways to help square the robot up to the wall, which means your drivers won't have to be as careful when lining up to score. The less precise your drivers have to be, the faster they'll be able to score blocks. Another feature of the drivetrain is that it's designed to fit under the low bar of the supply zone. One of the challenges of this game is that your robot has to reach into the supply zone to collect blocks. If your robot can't reach into the supply zone, you're much more limited into the number of blocks you can score. By driving under the low bar, Byte gets access to even more of the blocks in the supply zone. Byte's arm is a simple swing mechanism designed to get blocks from the floor to the top of the goal to score. The block doesn't need to stay on a specific path, so a more complex arm is not needed. If you want to learn more about complex arms, please visit the link to the article, Building VexIQ Robot Arms, in the description below. Byte's arm has a 5:1 gear ratio at its joint to lift the arm up with ease. This gear ratio increases the torque and reduces the speed of the motor by 5 times. If the arm was direct driven by the motor, it wouldn't have enough torque to require to lift itself. Proper gearing on a robot is very important and can ensure that you have enough torque to lift up an arm or speed up a drivetrain. For more information on robot gearing, please visit the link below for the knowledge base article on using VexIQ gears. Another subtle design feature on Byte is the location of the intake motors, which aren't actually located on the intake at the end of the arm. Instead, the intake motors are located closer to the arm's pivot point. As a weight moves further away from the arm's pivot point, more torque is required to lift it. By moving the heavy motors closer to the arm's pivot point, less torque is required from the motors to lift the arm. Keeping the intake motors close to the arm's pivot point also helps keep the robot's center of mass between its wheels, making it less likely to tip over when the arm goes up. The counterweight on the front of the robot helps stabilize the robot. You'll notice that Byte's arm doesn't have a stop and can flip all the way to the back of the robot. In testing, we realized that without an added weight on the front, the robot would actually be able to fall over as its arm moved forward. Byte's intake was designed to pick up the green or the purple blocks, and it can hold either 2 of the green blocks or 1 of the purple blocks at a time. To account for the different block sizes, the top of the intake can move up and down to fit either size block. A spring on the top of the intake compresses blocks and makes sure they don't fall out of the arm when it moves. Something new for this year's HeroBot is that Byte uses sensors to assist both driver and autonomous control. A bumper switch gets pushed as a block enters the intake to let you know when the robot has successfully picked up a block. An optical sensor in the intake can tell you what color of block you have picked up. Byte can use this information to make decisions based on what actually happens during a match. For example, you could use the data from the optical sensor to keep intaking until the robot picks up a block of a specific color. We've also added an IQ Touch LED to the top of the robot. Using the color information provided by the optical sensor in the intake, Byte can display the color of the block in its grasp. The final sensor on Byte is the distance sensor, which is probably most useful for autonomous skills runs. When the arm is up in the scoring position, the distance sensor can tell the robot how far it is from the goal. This will help put the robot in the correct position to score consistently. You've probably noticed that Byte can't do every task in the game, and that wasn't an accident. We know you will find ways to improve on our basic design to play the game even better. Maybe you'll change the drivetrain. Maybe you'll rebuild the intake. Perhaps you'll take what you learned from Byte about mechanisms and sensors to apply it to an entirely new robot of your own design. We look forward to seeing what you do and learn with Byte this season. And we hope you have as much fun with Byte as we have.